m square plus 1, right? Bro? The yesterday we were talking about, and we said that this one is the smallest value. What is this? One more time. This is called the smallest value. M square minus 1 second smallest value, or m square plus 1 is always the greatest value, right? And now we studied. We had done yesterday a question number 12, I think, right? Read out the question number 12. What was that? Yeah. Question number 12. No. I'm talking about the example 6. I'm sorry. Example 6. I'm talking about. In the Pythagoras, this forms the Pythagorean triplet, right? This structure, we can say this expression makes the Pythagorean triplet, right? And where if you take the value of the anything, whatever you want to take anything, okay? Whatever you want to check, that value of the put there, and here and here, whatever the number you will get in the result, that result will be the Pythagorean triplet always, okay? Let me tell you what I'm talking now. Yesterday it was said that 2m equal to 12, right? So m equal to, we can say 6. We can say 6, okay? The first number now you can see there, from the Pythagorean triplet, the first member we got 12, okay? The second we need to get m square minus 1. What is the value of the m here? 6 square minus 1, you will get here 36 minus 1, so you will get 35. And now we have to get m square plus 1. So what is the value of the m here? So you will get 36 plus 1 equal to 37. The Pythagorean triplet we got here. Tell me the number. Triplet 12, 35 and 37. And we studied the Pythagorean triplet. What we studied, that the sum of the two numbers is equal to sum of the square of the two numbers is equal to the square of the third number. Then they are called a Pythagorean triplet. I mean, those numbers are called a Pythagorean triplet, right? Wrong? Let me tell you what I'm saying now. I'm just telling you now. 12, 35, and 37. Always I tell you, when the numbers are given in this way, so always we have to just remove the greatest number from the picture first of all, okay? To check that they are Pythagorean triplet or not, okay? So what is the greatest number here? 37. So we have to tag this number. This is smallest number, okay? So 12 square plus 35 square, okay? 35 square, right? Now 12 square 144, 35 square 1225, right? After adding this one, you will get the same as is the 37 square, right? Now they will be equal to each other, right? Now that's why I can say that, or we can say that these are whose numbers? What numbers? We can say 12. We can say 35, 12, 35, and 37 are the Pythagorean triplet. Okay, let's come back to the question now. Exercise question number, you can come evaluate. Yeah, question number 6, 3b. Write a Pythagorean triplet whose smallest number is 6. Okay, first number question. Can you see that? Member, thank you for helping me. Read out the question one more time. 6 number. Okay, again the same story. And how many questions are there? 4 questions are there. Same story we have to play. We have to play the game. Same story. Hey, where's the book? Take out the book. 3b. Quickly. Six number. Put your hand there. Like a child. Today, you were not there yesterday in the class. Why? Why did you come back? Who told you to come back? No, that's great. Let me tell you now. So here in this time, the question is again the same thing we have to do. How many questions are in this question? 4. 4, right? Wrong? The question number 1. The question is there. Again, you can see there the smallest member. You can see there. The word is smallest member. It means we have to write 2m equal to. Tell me. I hope I can show that. You get what I'm saying now? Let me tell you what I'm saying now. I'm just telling you now. The first number question, sir, solution. The smallest value is given there. That is 6. The smallest value is given that is 6. It means 2m equal to 6. M equal to 3. Can we do that? Can we do that? Tell me now. Let me tell you what I'm saying now. I'm just telling you now. The question arises here. So the smallest member is given there. That is 6. What is this? To get the value from I'm from here. Now can you find out m square and m square minus 1? Can you find m square plus 1? Calculate directly. M square minus 1. Calculate directly. What do you get? M square plus 1. Huh? You'll get 10. So I can say that, or we can say that. What we can say. So 6, 8, and 10. These numbers will come out. These numbers will come. I mean, I'm telling you, don't put your eyes there. This is morning time. I don't want to do anything now. You will say, sir, the problem is here. The problem is here. Sorry, not a problem. The question is here. The smallest member of the from the Pythagorean triplet. One of the member is given. That is 6. Do you feel what I'm saying now? So guys, 2m equal to. Yeah, you will just write a solution and the smallest member. Sorry, not value. Smallest member. It means 2m equal to. What I said in the Pythagorean triplet, I said to you that 2m, m square minus 1 and m square plus 1. Always in case of the natural number except 2, in case of the natural number, okay, always consider 2m as the smallest member from the Pythagorean triplet. 2m, m square minus 1 and m square plus 1. From all three members, in the Pythagorean triplet, this is the smallest value, okay, or we can say the smallest member. We can say that. Can we say that? Yeah, in case of the natural number, except 2, value of the m equal to 2, except 2. In the rare case, we can say, and otherwise, all time, we will get the 2m as the smallest value. You will see it like this. I've been telling you for a long time. I have been telling you. Now I'm just watching the same thing again. You are doing the same thing. Next time, I'll not tell you. You will get the heat. So 2m, m square minus 1 and m square plus 1, right? So from all these three, the 2m is the smallest value, right? Or the smallest member of from Pythagorean triplet. Can we say that? So I can say right now 2m equal to 6. So m equal to 3. Now we got the value of the m. Now it is very easy to find out m square minus 1, m square plus 1. Then you will write m square minus 1, 3 3 9 minus 1, you will get 8. Let me write it the proper way. And after that, m square plus 1. M square plus 1. You tell me. 3 square minus 1. 9 minus plus 1. Plus you will get 10. Yes? So we got the Pythagorean triplet here. What are the numbers? Numbers are 6, 8, and 10. 6, 8, and 10. I hope you show that. Put your eyes in second number question. 40, 14, 14, 14, right? 14 now.
Yes, sir. What for 14?
What are you saying?
14.
What I am saying?
14. Pronunciation is 14.
I said 14.
Yeah.
You just write the smallest member of the Pythagorean triplet. The smallest member. Equal to 14. 2m equal to? I'm equal to. You tell me. I'm square minus 1. 49 minus 1? 48. You tell me. I'm square? You tell me. Thank you. 50. So we can say that 14, 48, and 50 are the Pythagorean triplet. Are the Pythagorean triplet? Why it is so? Because the sum of two smallest number, or we can say sum of the two numbers, the sum of the square of two numbers is equal to the square of third number, or we can say the square of greatest number from the Pythagorean triplet. Can you say that? So right now, what we can say, you will say that. So here we can say, what we can say now, we can say that. So 14, 48, and 50. This can be written. Somebody can write like this way as well. By don't be confused. Somebody can write like this way. The Pythagorean triplet. While writing the Pythagorean triplet, somebody can change the order. No, that doesn't matter. It is written like that. Somebody writes. For example, let me tell you what I'm saying now. I'm just telling somebody can write 14, 50. So don't be confused here this time. So the order is not correct. Right? Order doesn't matter. What I'm saying to from these numbers, what we have to do, we have to see that what is the greatest number here? 50. It is written in this way, in that way, doesn't matter. First of all, if somebody asks you the question, are these numbers a Pythagorean triplet or not, you will check it. The sum of the square of two smallest numbers. What are the smallest numbers here? 14 and 48. So you can say the 14 square plus 48 square equal to 50 square. Tell me now, yaar. So now in this one, the 14 square 196. You tell me 48 square.
2304.
Thanks for helping me. 2304. Okay, 2304. 2304. Okay, that's great. 6 plus 4. Carry 9 plus 1 0. Carry 3 1 5, and it will be 2. The 2500. Let's do it. So you will get the 2500. So here we can say what we can say now: the 14, 50, and 48. Okay, order doesn't matter. Whatever the order is written doesn't matter. But always just write in the proper way. When we just write the Pythagorean triplet, write in the proper way. Write the first smallest number, and then second smallest, and then third greatest. Okay, or we can say the greatest one. So guys, what will you write here in this time? 14, 48, and the 50. This is the way it should write in the Pythagorean triplet, right? When we just represent the Pythagorean triplet, so we will just write like this way. I hope you can show that. Can I solve two more questions?
Yes, sir. Yes, sir.
So what did I write in the third number question? 2m equal to
16. Then I will compare it and then I will start
I hope you can solve the question. Fourth number also you can solve the question. What is given the fourth number value? 20. The 2m equal to 20. I wanna. So here, I hope you can solve all the questions of the 6 number. Now let's come back to the story. Property at 11. Read out. The property 10 completed. No questions. If you want to ask any questions, you can ask me in the property number 10. Otherwise, we will just discuss the property number 11. Property 11, we can put a hand up property 10 and 11 together. And if you want to ask any questions from the property 10, you can ask the question. Otherwise, we'll just move on property 11. You can go, move on. Do your work, none of your business. Kamil, don't force me to speak anything against you. Don't force me to do anything against you. Where is the book? Put your eyes in your book. Abbas, where is the book? I'm sorry? Afar, where is the book? Somebody touch somebody's book. Somebody touch somebody's book. Wow, that's great. It's a great thing you're doing. I'm sorry? Come again. Come again. You saw something? Now, in this time, property 11, let's put it as the property 11, one by one, just like a child, okay? One more time. There are 2 and one more time. When the body is saying the consecutive, one after the another. When we say the consecutive, one after the another, or one just after, we can say that. Okay. Now understand here. Understand. Keep watching the board. So it is saying the n square, and it is saying n plus n ka whole square. Okay. Now first of all, understand the meaning of n plus 1. If somebody tells you n and somebody tells you n plus 1, just you will say these two things are the consecutive things. Consecutive things. Why? Listen up. Because if somebody writes 7, value of the 7 n equal to 7, definitely this will be 8. Absolutely. Yeah, 8. I'm sorry. It will be 8 because 7 plus 1 equal to 3. Because I can say that 7 and 8 are the consecutive numbers. 7 and 8 are the. Can we say that? For example, if somebody putting the value, somebody puts the value here, 12. What will be? 30. 30 it will be. Now you tell me, say 12 and 13 are called the consecutive numbers. Consecutive numbers they are called. Can you call? Consecutive means what? One after the another, just to another. Okay, that is called consecutive numbers, right? Can you call? Let me tell you now one more time. So when the word is saying the n plus 1, to always keeps in the mind they are called consecutive numbers, right? Let me tell you one more time. For example, somebody tells you x and x plus 1 and x plus 2, to always keep in the mind, or x plus 3, to always keep in the mind these are the consecutive numbers because increasing by 1 all the time. Get up what I'm saying now? So I can say x plus 1, x plus 2, x plus 3, because now x, adding 1 to the x plus to the x, you'll get x plus 1. Adding 1 to the x plus 1, you'll get x plus 2. Adding 1 to the x plus 2, you'll get x plus 3. Right? So these are the consecutive numbers. What I'm saying, for example, you will put the value x here 3, so definitely this will be 4. This will be absolutely, because 3 plus 2 equal to 5 now. Yeah. Here you'll get absolutely, and keep going on. So I can say that 3, 4, 5 are the consecutive numbers. Can I say that? Okay, now let me discuss now. So somebody tells you n plus 1, it means the n and n plus 1 are the consecutive numbers. Whatever the value of the n, whatever you can put here, no problem, doesn't matter that. Put the value of the n here, anything, whatever comes to your mind, right? So value of the n here, you can put anything, whatever comes to mind, okay? Let me just, okay, now, so, I mean, you tell me. Just try the value of the n, anything, whatever comes to mind. Yeah. Yeah, put anything, any natural number. 11, that's great. So here you'll get 11. Now here, what will you get? N plus 1, so you'll get 11 plus 1. What will you get, guys? 12. So I can say that 11 and 12 are the consecutive numbers. And the word is saying that when the two things are there, n squared and n plus 1 ka whole square, it means it is nothing but, it is increasing, it is nothing but the consecutive, it is just adding 1. This number we got here, adding 1. It means n and n plus 1 are the consecutive numbers. Let me tell you now what I'm saying now. I'm just telling you, and the word now what is the property? Property is saying that when we are just string the consecutive numbers square, n square and n plus 1 ka whole square. If you are doing this, then we will get the 2n non-perfect square number, non-perfect square number. I mean, we will get the 2n. It is the number of the non-perfect square numbers. So we will get 2n. What is the meaning of this one, right? Try to understand very quickly. We will understand. We don't have time. Time is passing. We don't have only 5 minutes left. N square and n plus 1 ka whole square. Okay, you're watching. Look at the board. You're watching. Your work is here, not your work there. And that's my work. N square and n plus 1 ka whole square. Okay, 2 numbers are here. Okay, keep watching. Understand now. Sir, for example, I'll take the value of the n here. Anything. Put here anything. Whatever comes to mind. I'll put 3. Okay, I'll put 3. Put anything, whatever comes to mind. Okay. Now you tell me n square, 3 square. What will you get, guys? What will you get? You'll get 9. You'll get 9. So I can say that value of the n square here we got here. Value of the n square. Value of the n square we got here 9. Okay. Let's do this one. You will say, sir, n plus 1 ka whole square. So somebody can say what is the value of the n here? 3 plus 1 ka whole square. 3 plus 1 equal to 4. 4 ka whole square? 16, right? Now, what was the value of the n we had taken? 3? 3? Okay, let's find the value of the 2n. So we can say 2 multiply 3. What is this? 6? Now, let's understand something here. Sir, 10, 11, 12, 13, 14, 15. Now count all these numbers. How many numbers are there? 6. And you tell me all the numbers 10, 11, 12, 13, 14, 15 are the perfect square numbers, non-perfect square numbers? Non-perfect square numbers? How many numbers are there? No need to check like this. Directly we can say you will get the 6 non-perfect square numbers between n square and n square plus 1 when the value of the n equal to 3. Let me tell you one more time what I'm saying now. Non-perfect square, non-perfect square number, non-perfect square number, non-perfect square number, non-perfect square number, non-perfect square number. 1, 2, 3, 4, 5, 6. I think this is confusion. I know you're confusion. For example, what I'm saying to you, n square, n plus. When the word, whenever in the mathematics, n is given, k is given, not k, n is given, x is given, a is given, b is given, so always considered as a number there. When we say the word n squared, it is talking about the any number is square. When the word is saying any number is square, we are talking about, right? When the word is saying the n square, it means the value of the n can be any number. It can be positive, it can be negative. But right now we are dealing with the positive. That's why we'll discuss about the positive number, right? Let me tell you what I'm saying now. When the word is x plus 1, x plus 2, x plus 3, so always keep in mind when the word is x there, it is talking about the any number. Value of the x can be any. Advance, don't do that. Don't move your bullshit leg. Disturbs me a lot. When the word is saying n squared, what will you consider as n?
Any number.
You will consider any number here. Okay, let me tell you now. So here, let's put anything. So this time, I'm taking here the smallest number, the smaller number, because whatever we do with the smaller number, the same thing concept will be applied with the larger numbers, right? Because let's take 3,000, a bit 3,000, and just check now. How can I? Of course, we can do that, but the problem it will take a lot of time. Of course, we can find out. No? Value of the n equal to 3,000 squared. Okay, whatever the thing applied for the smaller number, same concept applied for the larger numbers, right? So here, let's come back here. What we can do now, here, let's put anything. So this time I'll put n equal to 4, right now? N equal to 4. You tell me, n square, what will be? It will be 16? Because 4 is square. 4 square. What will you get, guys? 16. Okay, n plus 1 ka whole square. So what we took the value of the n? 4. So 4 plus 1 ka whole square. So 4 plus 1 equal to 5. 5 ka whole square? 25. The value of the n square, n plus 1 ka whole square, we got 25 ka? 25? We got 25? Now we can say that how many non-perfect square numbers are between 16 between n square. Keep in mind, I am talking about the n square. I'm not talking about the 4 and the 5. Hey, I'm not talking about the 4 and the 5. No. Don't be confused. We are talking about we are dealing with the n square and n plus 1 ka whole square. We are not dealing with the 4 and the 5. How many non-perfect square numbers? There is no number that exists between 4 and the 5. That's no numbers exist. Don't be confused. What I'm saying now, the question is saying between n square and n plus 1 ka whole square. So how many non-perfect square numbers are there? Between
N square and n plus 1. N square and n plus 1 whole square.
you are saying the n only. You stopped there for a moment, for a second. Now what I'm saying now, the word is saying that between n square and n plus 1 ka whole square. Do you feel what I'm saying now? So how many non-perfect square numbers? Somebody asks you, how many non-perfect square numbers are between 4 and 5? What do you mean that? How many? First of all, there's no integer exist between 4 and 5. Decimal numbers exist, fractional numbers exist, irrational number exist, rational number exist, but I cannot say an integer exists. I gave you the warning, but you don't understand that. Look at the board. Let me come here. Put your eyes there on the board. No, you cannot do that. What do you mean chal jata? What do you mean that? What I'm saying now, the word is saying, the question is, now you tell me. So here we have to say the non-perfect square number between 16 and 25. You're getting my point? We have to say the non-perfect square number between 16 and 25 because this is square of 4, and this is square of and a 4 plus 1 का whole square, right? So we have to get the non-perfect square number between 16 and 25, or we can say we have to get the perfect square number between 4 square and 5 square. We have to say like this. We have to get the non-perfect square number between 4 square and 5 square. 4 square equal to or 5 square equal to, and yeah, 4 plus 1 you will get 5 now. You will get. So we have to get the perfect square number between 4 square and 5 square, not the 4 and 5. 4 square and 5 square. So also we can say that this is the square of the two consecutive numbers. Why? Because it is n square, it is n plus 1 square, n plus 1 ka whole square, right? So now somebody asking you how many non-perfect square numbers exist between 16 and 25, you will say, sir, what is the value of the n here? 4. So you will say the 8 numbers are there, not 8. 8. I'm not saying the 8 exist. No. 8 number of non-perfect square numbers between
16 and 25. Between 16 and 25.
First you man mistake and you're just smiling. Smiling at me? Huh? Then whom you are smiling? What do you mean situation? No, why did you smile? Question arises. What do you mean automatically? Somebody made a mistake and somebody will smile. For example, there's a thief here and there's a police here. A thief is theft something or thieving something. It is the word thieving exists in the grammar. Huh? Stealing. Thank you for helping me. Thank you for teaching me today. It's a new word. Stealing, we can say. Thank you for teaching me. Let me just tell you now that stealing, right? And stealing as laughing. The police will say laughing, taking out the purse and laughing. What will happen? I mean, the public place. For example, in the bus, okay, a thief, okay, a thief is stealing something from the pocket and laughing. There's a man laughing and take out some laughing. Hello, I'm laughing. What do you mean that? Making mistake and laughing. No, I hate stories. I really hate stories. What do you mean? The word is here now. The question is saying that how many non-perfect square numbers are there between n square and n plus 1 ka whole square. Directly, no need to check that. There are how many non-perfect square numbers? Directly, we can say the 2n. How many? What is the value of the n here? Let's put here. So how will you get? How many? 8. So no need to, if somebody wants to check, sir, I want to check. You tell me how many numbers exist between 16 and 25. You will say, sir, 17, 18, 19, 20, 21, 22, 23, 24. Can we say that? So these numbers exist. Now count all this one. 1, 2, 3, 4, 5, 6, 7, 8. And all these are non-perfect square numbers. Can we say that? All these are non-perfect square numbers. 17 is a perfect square number. Now read out the property 11 again.
Two consecutive square numbers and square and there are non-perfect square numbers.
So what I'm telling you now, the how many non-perfect square numbers exist between n square and n plus 1 ka whole square, you will say 2n numbers. It means here 2n talking about 2n talking about number of non-perfect square numbers between n square and n plus 1 ka whole square. So when we say the n and n plus 1, it means we are talking about the two consecutive numbers. Why? Because n plus 1, what is n plus 1? It is just adding 1 from to the n, we will get n plus 1. Just adding 1. And how will you get n plus 1? And the n plus 1. How did you get the n plus 1? How did you get this term? You will say adding 1 to the previous term. We got this term, adding 1 from the previous term. Comment, don't do that. Don't do the highly constant on the board now. I hope you understood that. Can you try the examples by yourself? Now you can check. Now, just like a child we are doing, and as a professional, boys and girls we are doing. The professional, we should not say professional.
Sir, like this, n plus 1.
Here?
Yes, sir.
Which one?
Formula.
Yeah.
N plus 1.
Yeah. N plus 1.
Plus 1.
Yeah.
Bracket.
A small bracket.
Then minus n.
Minus n. Yeah.
Then big bracket. The big bracket.
Then
After
big.
that, right there, minus 1.
Again?
Yeah, minus 1.
Minus 1. Yeah.
Which is also coming. That 8. Each and every digit. How much the number of non-perfect square between these
Hmm.
you can got in this way.
2 plus 1 5. 5 minus 4.
Simply you can say last number minus first number and
Last number it is what is this? Or last number minus first number?
yeah. Sorry, square sir. L plus 1 ka square.
Oh, square it is.
Yeah.
Okay.
And n square.
Oh, here n square.
Yeah.
Okay.
We can in this type of question we
Minus 1 also.
minus 1.
Okay. So
So n plus 1 ka whole square value is 25 in this question.
25. Okay.
Put there 25.
Here I put there
Directly.
directly 25. Directly 25.
Yeah. Solve that.
Oh, minus?
Minus that's 16.
Huh?
N square is 16.
Minus 1 is 16. Okay.
Yeah, 16.
Yeah.
Solve it.
Minus 1.
Yeah.
Minus 1 no?
Minus 1.
Minus 1. Yeah. 25 minus 16.
Yeah.
9. Minus 1. You are saying add.
Yeah.
Number of non-perfect square numbers add.
Yeah.
That's a great observation. I love this.
It is satisfying all the cases.
We have to check. It's your homework for you. You will check in all the time.
Six.
Checked? That's a great observation. I love this. I'm sorry? It is the original form of? Student is the short version. Yeah, of course, calculating this one, perhaps you are saying that. Actually, you are deriving the formula, I think. You are saying that. So, n plus 1 ka whole square, you will get n square plus 1 plus 2n, okay? Minus n square minus 1, right? So, n square will be cancelled out, right? Right? So, it is 2n plus 1 minus 1, it will be cancelled out. So, here you are getting 2n. What was the problem if I wrote the 2n here? Okay, that's what I said. I love that. What I said. Yeah, of course. Because now, this 2n can be derived or can be written in this form. Now you tell me, more complex, less complex. You tell me. You have to decide. You tell me, which one is the easiest one? 2n or this one? Huh? No. Success path नहीं करना है. If you just like this one, you say, sir, follow that. Follow your own way. Yeah, success path नहीं. ये teacher path नहीं करना है. Sir, I like this way. I will do that. Can I do this? Of course, 100%. ठीक है जी? Teacher path नहीं करना है जी. खास के मेरे सामने. Let's go. I hope you understood that. So let's do the example now. So we can do what we can do here. Property 11, right now? Solution. Okay. Property 11, right?
Sir, property number 11.
If you don't want to speak, no problem at all. You can just, I can leave the class.